Alright guys, so good evening once again, and thank you for joining me in today's class where we are going to conclude linear motion or motion in one dimension. So we are going to conclude this topic today. That simply means that the next time we shall meet, we shall be looking at projectile motion. So please feel free to ask questions, feel free to participate, because you only understand more when you ask questions and when you participate. All right, so one thing I'm going to assure you is that these things are very easy if you practice much. These things are very easy when you practice much. Okay, so in today's class, like I've already stated, we're going to look at uniformly accelerated motion, or in other words, we can say motion in one dimension. So that's the same thing. So for theory, I explained in the previous class. So please make sure that you watch the previous class. So for today's class, I'm only focused on solving. So we'll look at our first example, which has been projected. So the first question is saying a runner makes one lap around a 400-meter track in a time of 50 seconds. What were the runner's 1. average speed, 2. the average velocity? This is a very nice question. This is a very nice question which each one of us is supposed to have interest in. So I'll write my solution. There. So I'm just kindly asking if you guys can tell me if I'm audible enough or not. Can someone confirm if you guys can get me? Are you able to get me?
Yes, sir. You are audible, sir.
Alright, thank you. So a runner makes one lap around a 400-meter track in a time of 50 seconds. What were the runner's 1. average speed? So one thing you need to understand is that according to the theory we learned last time, we said speed is what quantity? Is speed a scalar or a vector? Can someone respond? Is speed a scalar or a vector? You can just unmute yourself and state what you think. Did people attend the previous class? Is speed a scalar or a vector quantity?
It's a scalar quantity, sir.
Correct. So speed is just a scalar quantity. Speed is a scalar quantity, and then velocity is a vector quantity. So in this case, we are just trying to apply that the theory behind a vector and a scalar quantity. So from here we have been given the distance and we have also been given the time. Okay, and then there is also the statement which we need to understand. So in such a case, we are saying find the average speed. So we need to understand that average speed, which is average speed, I'll write it as average speed, is simply equal to distance traveled. Is simply equal to distance traveled over what? Over time. So if you check from the question, the distance that has been traveled is just simply what? 400 meters. So we are going to say 400 meters over 50 seconds. Okay, 400 meters over 50 seconds. What are you having when you say 400 divided by 50? What are you having? Someone with a calculator to quickly. 8.
8.
All right, so that's correct. So in this case, the answer is just 8.0 meters per second. Remember to put the SI unit. Okay. So the next one is where we are trying to look at velocity. We have the same information, but we are looking at velocity. So if you look at velocity, velocity is simply equal to displacement, over what? Over time. Can someone tell me what is the value of displacement in this case? What is the value for the displacement? Someone to give it a try. What value are you going to put on the displacement? From the statement, what do you understand? What is the value of the displacement? Ladies and gentlemen, can we participate so that we can move at the same pace? Okay, all right, seems like no one knows. Okay, so let's assume this is our track and this track is 400 meters. Okay, so if this person starts from here, okay, so according to the information, there is what we are saying makes one lap around. Okay, so this is the statement which can help you to know the value of the distance. Makes one lap around. Okay, can someone tell me what do you think this statement mean? Make one lap around. Can someone give it a try? What do you think this statement is trying to tell us? Florence, can you give it a try?
I can lie if I don't know.
Okay, so the question is saying a runner makes one lap around. So this simply means that if the runner started from this starting point, okay, this runner had to move from there, moving, running, and then he had to end at this same point. Okay, and then the total distance for this particular movement which he made was just what? 400 meters. So we can assume this is 100, that is 100, that is 100, that is 100. Okay, so since the runner started from this point and he has ran around this field and he has stopped at this same particular point, so that simply means that this person covered a displacement of what? Of 0. So the displacement here which was covered was just simply what? 0 meters. Why is it 0 meters? The reason is that he ended where he started from. According to the theory which we had to discuss last time, we discussed some certain moving object which we talked about, the one which went toward the positive and then it went back towards the negative, covering about 6 meters. So 6 meters going this side and 6 meters going the other round, and we said that the velocity for that particular object was 0. Okay, same applies with this guy. The displacement in this case, starting from the starting point, he had to run around this track and he ended on the starting point. So in such a case, the displacement is simply what? 0. So time will still be maintained, which is 50 seconds. So in this particular case, you can simply say 0 divided by 50 is just simply 0 meters per second. So this is the answer for this question. Do you have any questions, ladies and gentlemen, before I move on? Okay, seems like we don't. Okay, since we don't have any question, we can move on. So the next question is that an object starts from rest with a constant acceleration of 8 meters per second squared, okay, along a straight line. Find the speed at the end of 5 meters 5 seconds, and then B, the average speed for the 5-second interval, and then C, the distance traveled in the 5 seconds. So that's the question that we have and we are asked to solve. So from this information which we have been given, we can correct the data. So you need to understand that the acceleration which we have been given, which is simply A, is simply 8 meters per second squared. And then if you look at time, which is T, it is just simply what? 5 seconds. So we have been given this data, and then what we have been asked is, one, to find the speed. Okay, one, we have been asked to find the speed. Two, we have been asked to also find the average speed. So this one is very easy to go, and this one is something that you just have to apply some few concepts that you can apply. And then the last one, you have been asked to find the distance, which is also unknown. Okay, so let's quickly move on and work out this question from this side. So from this information, we can work out the first one, which is find the speed. This is the speed and not the average speed. So if you look at the information which we have been given, where we are only interested in the motion in the first 5 seconds. So one thing that we can do is, let's take the direction to be positive. Okay, the thing that we can say take direction. Okay, take direction to be positive. So we are going to take the direction to be positive. And then another thing that we can consider is that we can also consider the speed, and also we can also take note of the initial velocity. So since this guy is starting from the rest, that simply means that the initial velocity is simply what? 0 meters per second. For some books, we can say VI is equal to what? 0 meters per second. So with this information that we have, we can utilize one of the equations of motion, which we can look at, and we can simply find the average speed. So let's quickly look at one of the equations that we can use. So we can use the equation whereby we say VF, okay, VF, which is velocity final or speed final, is simply equal to, we can say V initial, okay, the velocity initial, which is 0, and then we can simply say plus C AT, where T is simply the what? T is simply the time. Then from this information, we can simply say VF is simply equal to, what we can say is, we get the information, the initial velocity we had was 0, or the initial speed was 0. So you can say 0 plus, and then if you check the acceleration was 8, and then if you check the time was simply what? Was simply 5 seconds. So from this, you can quickly check out the multiplication there. So the velocity final is simply equal to what? 40 meters per second. So this was the answer for this particular question. Then the other part which we can work out, is our B. So if you look at our B, we have been asked to find the average speed. So for the average speed, we are going to use the formula for finding the average speed. So average speed is simply equal to the velocity initial plus the velocity final over 2. The velocity initial over the velocity final over 2. So with this information which we have gathered here, we can simply say what we had for the velocity initial was simply 0, okay, was simply 0, plus the velocity final which we have found is 40. So you're going to say 40 over what? Over 2. So 0 plus 40 is simply 40. 40 divided by 2 is 20. So our average velocity is just simply 20 meters per second. So these are the two ways you can one, look for the velocity final, two, you can now look for the average velocity. So that's how easy you can work out that question. I don't know if there is any question, ladies and gentlemen, before I go to C. Any question, ladies and gentlemen? Do you have anyone with a question? Okay, I have seen Taonga has a question. Taonga, what's your question?
So here, why are we dividing by 2?
Okay, so when you talk of average is just whereby you find the summation of what you have been given over the quantity of what you have been given. So in this case, we only have the initial and the final velocity. We only have the initial and final velocity. So because these are the only two values that we have to divide by 2. So according to math, if we borrow the knowledge of math, you can say summation of everything over the quantity of everything. So the reason why we are dividing by 2 is because we only have the initial velocity and the final velocity. Is that okay?
Alright, thank you.
You're welcome. So we can now look for the distance. So we know distance, I can use it using the x. So x is simply standing for distance. So distance can be found by using the formula distance is equal to v initial multiplied by time, and then you can say plus 1 over 2 80 squared, 1 over 2 80 squared. So from this information, from this formula, you can say distance is equal to the initial velocity here is just 0, so you say 0 times time, which is 5, and then you say plus, you can simply say half multiplied by 8 and multiplied by what? 5 squared. So x is simply equal to, if you work out that, you're going to have you're simply going to have 5 squared, which is 25, right? 25, and then 25 times 4, because 2 into 2 1, 2 into that, it's 4. So you're going to have 4 times 25. Okay, 25 is coming from 5 squared, and then 4 is coming from the fact that 2 there, it's 1, and then 2 there, it is simply 4. Then this times that is simply 0. So then you can say 4 times 5 squared, which is 4 times 25, and x is simply equal to 100 meters. So this was the distance which was covered. Do we have any questions so far before we move on, ladies and gentlemen? So it's very important for one to take the theory part, like the theory which we learned last time and we looked at some certain formulas, you need to make sure that you also know all the 5 formulas that we discussed last time. Okay, so with this information, I can move on and look at the next question. So the next question is another question of interest. So the question is saying a car's speed increases uniformly from that to that in 20 seconds. So I can simply do the same thing by correcting the data. So if you look at this guy, we have been given that the initial velocity, which is vi, is simply what? 4.17 meters per second. Then the velocity final, which we have been given, is simply 16.7 meters per second. Then if you look at the time is simply what? 20 seconds. Okay. So with this information, you can easily work out the questions which we have been asked. The first question is find the average velocity. So I'm going to say A. So for the average velocity, it's something that can easily be found. So average velocity, which is V average, is simply equal to V initial plus V final over 2. Okay, then that you can simply say 4.17 plus 16.7 over 2. So if you work out that, simply going to give you the average velocity to be 10 meters per second. So this will be 10 meters per second when we work it out. We can go to B. B is also easy if you know the formula. B is also easy if you know the formula. So since we have the initial velocity, we have the final velocity, and we have time, so it's very easy for us to say acceleration is equal to change in velocity over change in what? In time. So in this particular case, we have the final velocity, which is 16.7 meters per second, and then we can say minus the 4.17 meters per second over the time we have been given is just simply what? 20 meters, 20 seconds. So if you work out your calculations, if you work out the calculations there, the answer will simply be 0.63 meters per second square. So take note of the SI unit. So that's where the SI units are playing a role in such a case. The next part is the distance traveled, which is our C. So if you look at distance, distance can easily be found. We can easily find the distance by utilizing the formulas or by utilizing the information which we have been given. So we know that average velocity or average speed, okay, we know that speed is equal to distance, average distance over time, average distance over time. So we can utilize this formula to come up with a formula that will help us to know the distance. So you can simply say x, standing for the distance, is simply equal to time times speed. So there you're going to say average velocity times what? Times time, which is t. So x is simply equal to, you're going to get your average velocity there, which was 10 meters per second, times the time which we have, which is the time which is simply 20 seconds. Okay, So if you look at the average time which we had here, it is a time which we had the average velocity which we had here. It's a velocity which we had to round off. Okay, so this will give you times 20, and this one will give you what? Will give you 200 meters. So this is the answer you can find if you go direct and plug in that guy. But if you check your calculator, when we don't round off, you're going to find that the distance you are going to find here, you can get the one for the value 10.4 meters per second. Okay, so this is the average velocity times what? Times the 20 second, and this will simply give you a different value, which is simply 208 meters. So there is much difference when you just pick the solution there, or you work out everything, and then you make sure that you are not rounding off. So there is bits of difference in terms of the answer. But for some lecturer, they can mark you this one correct and also this one correct. But the thing is, this one, it is a bit wrong because you had to use a rounded off figure. So that's why it's important to make sure that you don't round off, or you don't use something that has been rounded off. Okay, so this is the exam tip I've given you on this particular question. So make sure that you are very careful in terms of presenting your work. Okay, so with this in mind, I don't know if there is any questions. Do we have someone with a question so that we can move on? Okay, it's more like there is no one with a question. Do we have someone with a question? Feel free to ask. Okay, since we don't have any question from you guys, let's quickly move on and look at the next question. The next question is saying a stone is dropped from rest. Okay, a stone is dropped from rest. So we can pick our data. Let's say this is the point. Okay, this is the point, and then this point you have a stone there. We have a stone there, and this stone is made to drop. It's not thrown, but it's dropped. Take note of that. It's not thrown, but it has just been what? It has just been dropped. Okay. So when it has been dropped, that simply means that there is nothing like considering the angle. There is nothing like considering the angle because it has just been dropped. So a stone has been dropped from rest, so that simply means that the velocity initial is simply equal to 0 meters per second. So if you read the word rest, it's just telling you that the velocity, the initial velocity is 0. Then at a height of 50 meters, so the height from this point to that point is just 50 meters. I feel this was very tall, and yeah, very tall. So 50 meters above the ground. What is its speed just before it hits the ground? So in this case, we are looking for the V final before it hits the what? The ground. Because we know that when it hits the ground, there will be issues of the change of energy, there will be issue of some resistance. So in this particular question, one thing that you need to understand is that we don't consider the air resistance. So here you need to note that we are not going to consider the air resistance. So there is nothing like friction. There is nothing like friction. So when you talk of friction, we'll talk about it later when we discuss the Newton laws. So but for now we are just going to look at this. So let's quickly look at the solution. So the first part is we have been asked to find the speed. Okay, we have been asked to find the speed. So as this object moves from up going down, one thing that you need to understand that it's possessing it's having the force of gravity. There is the force of gravity which is acting on it. As it falls down, there is the force of gravity which is acting on it, and that force of gravity can be treated as the acceleration, and that means that the acceleration, according to the values which you can be given, one of the values which you expect is 9.81. So the acceleration which we can consider is 9.81, because this is equivalent to the force of gravity. This is equivalent to the acceleration due to gravity. So you can just simply force of gravity. I'm going to use the word force of gravity because this is the term that you guys can be familiar with. Okay, with this all information which we have been given, we can easily come up with a way of solving this question. But one thing that we need to understand, that we are going to consider there is no air resistant. We are going to consider that there is no air resistant. So the formula we can use is V final. The formula we can use is just simply V final squared is simply equal to V initial squared, and then you can say plus 2AT plus 2A plus 2AS, where AS or AX or AY can be used. So this Y is just talking about the distance. So some equation they say 2AS, which is just talking about the distance which has been covered. For some books there will be 2AX, and then for this one I'm using 2AY because we know that we have two axes. Okay, we have two axes. We have the y-axis and the x-axis. So I'm using y because this falling is happening in the y-axis. Okay, this falling is happening in the y-axis. That's why I've used y. So after you do that, you can say v squared final. V squared final is simply equal to the initial, we know it is 0, then plus 2 times 9.81 times the distance which we have been given, which is simply 50 meters. So V squared F is simply equal to, you can multiply that, you can simply multiply that. I'm sure you guys can easily work out that. So when we multiply that, it's going to give us something like, can someone multiply everything there? What are you having when you multiply? What are you having when you multiply?
$98.1.
98. Are you sure it's 98.1? 981. All right, correct. So it is 981 meters squared AC squared. Remember, this one has meters per second squared and that one has second squared. So from that, but this one is for me, like who knows what the units are, but for you, you can just write 981. So you introduce a square root, so that one and that one will go. So your final velocity is simply equal to, what is 981 981 square root of 981? What are you having?
31.32091953.
Okay, so we're just going to say 31.3 meters per second. So this was the final velocity before this particular stone had to hit the ground. Before it had to hit the ground, this was the velocity. So this information I'm giving you, it will be very useful when we start doing the topics that are coming, the topics that are ahead of us. When we start looking at circular motion, circular momentum, those things are very, very important, especially these velocities. And also when you talk about projectile motion, we'll also need this information as our basic information. So for B, it's saying, for B, please mute your mics. Florence, mute your mic. Okay, thank you. So for B, it's saying, how long does it take to reach the ground? So the term how long, okay, the phrase how long, it's just simply telling you the time, okay? How long will you take to come back? Then someone is just telling you how much time are you going to spend. So in this case, we have been asked the time, okay? So this one is very easy for us to know the time, for us to take note of the time. So we can use acceleration is equal to v final minus v initial over what? Over time. So if you make time the subject, the formula, if you make time the subject of the formula, you are simply going to have time is simply equal to, so this will simply be vf minus vi over acceleration. So all we need at this moment is for us to plug in the values. So if you look at the v final we have found is simply 31.3, and then you can say minus 0 and then over the time which we have, sorry, the acceleration, which is 9.81. so after considering that, you can say time is equal to 31.3 divided by 9.81. What are you having? Those who have solved, what are you having when you work out that? Do we have people who have utilized their calculator and found the answer? Okay, all right. The answer here is just 3 point.
I'm getting a 3.19.
Okay.
062.
Okay, so we are just going to put 3.19. We're just going to round it off to just 2 decimal places. So remember, time is in second. So this is how easily you can work out this question. If there are any question, feel free to ask and I will explain. Yes, there is a hand. Chishimba, what's your question? Chishimba, what's your question? Unmute yourself.
I didn't understand where you got the acceleration.
The value of the acceleration, because this guy is being dropped, because the stone is being dropped, that simply means that there is a force which is acting on it. So anything that is dropping, okay, anything that is dropping, it has a force which acts on it. So this is known as the force of gravity. Okay, the force of gravity. So we have the acceleration due to gravity. Okay, the acceleration due to gravity. So that acceleration due to gravity, which is, some books they write it as g, so it's equal to 9.18. so that's the value of the acceleration due to gravity. So this acceleration due to gravity is the same acceleration we are going to pick, and we are going to state that it's the acceleration which this stone was having as it was dropping. So anything that is being dropped, even you when you fall from a tree, there is the acceleration which you are possessing, and that acceleration, the average of it is 9.18 for some, sorry, 9.81, not 918, 9.81. For some books they'll say 10 meters per second. For some books they'll just round it off like that, but mostly you'll be given 9.81. So it's just the acceleration that every body which is falling has. Is that clear, Chishimba?
Yes, thank you.
You're welcome. Okay, so let's quickly, okay, I have another question from Frederick. Yes, Frederick, what's your question?
Yes, sir. There on question A, we asked to find the speed just before it hits the ground, but what we sought for is the final velocity. What's the relationship between the velocity and speed?
Okay, that's a very, very nice question. If you remember very well, we said, according to the theory we had, we said velocity and speed, sometimes these terms are being interchanged. And then if you look at the formula, the only difference that was there is that velocity had direction, but speed did not have direction. And then when you talk of the formula is almost the same. The formula is almost the same. The only difference that comes in is whereby, let's say someone starts from one point and ends on that particular point. So in such a case, velocity is 0, but the speed is normally calculated using the formula. Is that okay, Frederick?
I can say it is okay, yes.
All right, that's good. Okay, so we can move on and look at the other question. Okay, I can see a hand from Chimba. What's your question? Oh, not Chishimba, Florence. What's your question, Florence?
Yeah, it's not really a question, but I want to say the formulas are really disturbing me. Maybe if I would really appreciate you if we just need to have the formulas on their own to say, okay, this formula is for this formula is for this, because I'm completely confused.
Okay, we have 5 formulas that we discussed last time in the lesson, the ones which we had in the lesson. If you check the previous lesson, those formulas are there. Now when we talk of those particular formulas, your job now, like, there is a difference between now and where you are coming from. Where you're coming from is where you have to memorize something and put it the way like that. Right now, it's about you thinking, analyze, and then you know what am I supposed to apply? Which formula can I use? Sometimes you might choose this formula, you have that value for you to arrive at the other formula. So when after this class, go and watch the class which we previously had. It's on YouTube. Go and watch it. After you watch it, go and read the notes, and then I'll send more notes so that it helps you. Yeah. So the formulas, there's nothing like memorizing them. It's about knowing them and knowing how to analyze the equation and apply. Okay. So we can move and look at the next part. So a skier starts from rest, so that simply means that the initial velocity is 0, slides 9 meters, in that case we have the distance, down a slope in 3 seconds, that's the time. In what time starting would the skier acquire a speed of 24 meters? So this is the final. Assume that the acceleration is constant. So in this case, it's something that you need to understand that when you talk of this skier who has moved who has to slide 9 meters and is starting from rest, so we can say the initial velocity is simply equal to what? 0 meters per second. Then the time is simply equal to 3 seconds. Then you have the distance, which I can use x or y or s, is simply equal to what? 9 meters. Then the last one which we have is the final velocity, which is 24 meters per second. 24 meters per second. So from this information that we have been given, remember the acceleration has been kept constant, okay? And then what we have been asked is, in what time, starting with the skier, acquire a speed of 24 meters per second. Okay, so here's the thing. We are having the initial initial velocity, or the time, which is 3 seconds. So what we need to understand is that we must first find the acceleration of the skier. Okay, we must find the acceleration of the skier in the what? In the 3 seconds which has been covered. We must find the acceleration of the skier which he had in the what? In the 3 seconds which he was moving. Because we have been given a condition whereby this acceleration was kept constant. This acceleration was kept constant. So if we can find the acceleration within that period of 3 seconds, then we can easily work out the other time that we are now expected to find. So I'm going to write solution there. So like I have stated, let's find the acceleration in the what? In the first 3 seconds. So from here, from the data that we have been given, this guy has started from rest. Okay, that means that the initial velocity is what? Is 0. And we also have the distance, which is 9 meters. And then lastly, we have what? We have the time, which is 3 seconds. So the formula which is having all of this is the formula which we can say x is simply equal to x is the distance, isn't it? Distance is equal to v initial times time plus half and then acceleration time squared. So from this information we have 9 meters there, so you can say 9 is equal to, this is 0 since that one is 0, so we are now going to say that a and then time, which is 3 squared. After you have this information, you can cross multiply there, so this will be 18 is equal to 9a, of which a is just standing for acceleration. With that information in mind, you can divide throughout by 9. Acceleration is simply equal to 2 meters per second squared. So this was the acceleration that we have. Now, what we want is the time now which this person will spend to reach the acceleration, to reach the final velocity of 24 meters. We assume that this acceleration was constant. The acceleration was kept constant. There was nothing like changing. So we can now use this value of the acceleration for the other trip. So this one, we can now use this guy. So what we are going to do now is we are going to utilize the initial up to there. The initial will be maintained because that's where it started from. Okay, it's more like I'll pick something. Let's say this is a scar. Let me try to draw who is a scar. Whatever the scar looks like, I think what does a scar do? Okay, let me just draw a person moving. It doesn't matter if it's a scar or is whatever. I don't know what we can dress him up, but okay, let's dress him up with a crop top. Yeah, since crop tops are now the common clothes for people, so we are going to give this boy a crop top. It's a boy now. Okay, this is a crop top, and then with those strings like that. So this guy moves, let's say from this particular point, it goes up to that particular point. So from this point to that point, which this guy has spent 9 meters. Okay, so from this point to that point, he has spent what? 9 meters. That's the distance covered. And then the time he has spent is 3 seconds to reach this particular point. But this guy has maintained the acceleration to be the same. So this guy has moved again from this point going to that point to reach now a speed of 24 meters per second. So in this case, one thing that you need to understand is that from the beginning up to the end, from this point up to that particular point, this guy had the same acceleration. So this guy had the same acceleration. So because he had the same acceleration, we can utilize the information we have for his first trip to find the acceleration. That's the information we have now used. Now what we now want is to know the time is spent from this point to that point. What time did he spend? Okay, so we can easily utilize the formulas that we have to find the time. So you can say acceleration is equal to v final minus v initial, okay, over time. So from this information, you can simply say time is simply equal to V final minus V initial over acceleration. So time is simply equal to, the V initial is simply 0, and V final, we have already been told it has to be 24 meters. So it has to be 24 meters per second minus the initial, which is 0 meters per second, over the acceleration, which we have just found, which is simply 2 meters per second squared. So after we get this information, when you plug it in on your calculator, it will simply give you 12 seconds. So the time which this person spent from this point to that point was 12 seconds. So 12 seconds was the time which this person spent. Okay, so ladies and gentlemen, do you have any questions before I go on my last example on calculations that have to do with linear motion? Remember, I've given you an assignment, ladies and gentlemen. That assignment I've given you, make sure that you submit. In case you haven't submitted, submit, because after this class I'm giving another assignment in physics. So make sure that you submit. Let's move on and look at other stuffs. Let me just check if there is anyone with a question so that we can. Okay, we have a question from Chimuka. Chimuka, what's your question? Chimuka?
Asking if you can repeat how we found our acceleration.
Okay, so the acceleration was found